Good evening, wherever you are watching in the world. I shouldn't really be here. In absolute truth, I was planning for this to just play on its own, but the file was so large it's now stuck on the hard drive of my computer, so I'm going to have to play it manually, I'm afraid. So my apologies for that. I won't keep you waiting. But we are currently broadcasting, let me see, to 2 different Facebook places, LinkedIn, to YouTube, to Twitch, and to Instagram as well. So wherever you are in the world, please let us know where you're watching. Just drop a line in the chat. And I hope you enjoy it. If you've got any questions about the footage, please just drop those in as well. I am going to say a very good evening to Gary Muirhead, who is here. Good evening, Mark. Good evening, guys, and welcome to the first After Dark show of 2025. It is the first, but it won't be the last. We're already working on a few more. So if this kind of floats your boat, please let us know, because we'll be doing more. Dan Cullen's here as well. Good evening, everybody. And yes. Trying to find out more from my demolition friends up here. Yeah, there was a demolition collapse today in Anderston Quay in Glasgow. I'm hearing that nobody was hurt, but it was an unplanned collapse. Lots of debris. Apparently a van has been crushed and debris across the street. So I'm hoping everybody is all hunky-dory up there. But we'll be keeping up to date with that. If you want to find out more about that, you can go to demolitionnews.com. And there is Gary Muirhead saying, I'm watching from God's country. God's country indeed. Do you know there's actually a haggis in my fridge? Burn's night is fast approaching. I can't claim any kind of Scottishness at all, but I am going to be eating haggis. Jim Turner's just turned up as well. So I've kept you waiting long enough. I'm going to drag this film off my desktop. I can tell you in advance, it's about 35 minutes long, but it really is a fascinating story, which is precisely why I bring it to you. So let me just find the file. I'll set it to play, and then you can all watch along. Well, I'll watch along with you, actually. Here we go. Your story. 20 years ago, a 3-year-old boy pressed the button to initiate the explosive demolition of a bridge in Manchester. He clearly found the experience inspiring, because 20 years later, that little boy has just bought PDC, the company that did the bridge blast. In doing so, he has given the explosive demolition sector the takeover it has so long required. Demolition News sat down with industry veteran Robyn Rushforth and with the new managing director of PDC, Cormac McLean, for a long and detailed chat. And mark my words, this is what the future of the explosive demolition sector looks like.
So I originally have done stuff with John Faulkner literally 20 years ago. I had the privilege at Hexham House this past weekend of helping some children who'd won a competition press the button to bring down that tower block, and they all thought it was absolutely hilarious that the button we were using was 20 odd years old, and it was the same button that I'd pressed to drop a bridge in Manchester 20 years ago, and that was kind of what got me the bug and the spark in me. Still around, still doing a lot of jobs for us. It's our backup, but it comes out every now and then for a job. Unfortunately, I was going to bring it down today, but it's busy. But after this, it is going in a glass box. It's going on the wall. But so 20 years, and then the first time I worked with Robyn explicitly was 2021 down in Avonmouth, and then just a slow burner since then. On the age thing, did my degree. My degree didn't have a lot of massively useful content, so went to kind of cut my teeth. My first project, ironically, was about 300 yards that way on work experience, which was Lancaster House with Erith, and then worked full-time as a temporary works engineer for about 2 years, and then started with Robyn about roughly a year ago now, mainly in the engineering capacity, but slowly picking up the explosives bit.
But the ultimate goal is to presumably get the necessary experience and qualifications to obviously get yourself chartered, because that is definitely the way forward. The more high tech, the more academic approach we can take to blasting, that is the future for sure. We've got a couple of revolutionary or evolutionary, I don't know quite what the word is, techniques that we're starting to apply to things. There's jobs that people perhaps wouldn't consider as a blasting job that we're looking at ways we can do, because it saves a lot on hand-arm vibration. For example, one of the things that's being done in the London area quite extensively is removing concrete encasement from around steelwork, so the steelwork can be reused. Well, we have what we believe is a cunning, quick and quiet way that we can send a shockwave through that steel and make the concrete crumble and fall off it, as opposed to having guys there with jackhammers for hour upon hour upon hour.
I've just completed a management buyout of Robyn, having worked for the company for a year. So Robyn's sticking around indefinitely, but definitely for the next 3 years. We've chained him up for that much. And then I don't really know. It's a massive market. The demolition industry is fundamentally changing. I'm literally in the process of writing a dissertation paper about blasting's place in a sustainable economy. It sounds quite ironic, but certain structures of certain sizes aren't of a reusable nature. The elements inside them, a power station leg, you'll never see another coal-fired power station in the UK again, so there's no need for a power station leg. How are you going to reuse it? So it's best off recycling it, and then it's about basically the entire embodied carbon of the methodology section is the only way you can save and become as green as possible. And looking at some of the preliminary data from a job like Sizewell, the clean-up times and the size of plant needed to clean up have been halved, and the times have been slashed dramatically. And looking at the fuel burn saved versus the embodied carbon of the process that we do, it's trying to understand that balance and seeing, a truly academic process, what structures suit blasting the most going forward. And then obviously we're aware the UK market's finite in the industrial sphere. There's not a lot of deindustrialisation left. There's only 3 coal-fired power stations, 1 biomass power station of a size that we would be interested in. Some smaller gas turbine stuff eventually, but there'll be a long time yet. So it's broadening the horizons. In the last few weeks alone, we've been looking at projects all across Asia, all across the Middle East, Australia, actively tendering there. So it's trying to push out into those new horizons, and where mechanisation is not necessarily taken off yet, and people don't have 300-400 ton modified machines to pull down power stations, we can ultimately turn up in a pickup truck with a couple of wooden crates full of explosives and a local guy who knows how to use a cutting torch, and we can fell some sort of major structures without a lot of mobilisation cost and effort. So.
The traditional way of taking out large lumps of concrete, particularly power station turbine bases, alternator blocks and so on, is with heavy excavators and hydraulic breakers, obviously. They live in a very sensitive environment in that part of the world. There's been a lot of controversy with resistance to the construction of the new station that's going to go on down there. So they were very, very sensitive to environmental issues, noise, dust and so on. So the view was taken that a short, sharp crack, which could be publicised, could be managed and could be controlled, would then reduce the overall timescale and the inconvenience to the local people. So that's really the sort of driving force behind it. But obviously we then had an awful lot of technical problems that we had to approach and innovate to find solutions to.
It was the widest use of electronic detonators ever in the UK, and it was the longest ever electronic initiated shot in the UK. Lasted almost 14 seconds from start to finish.
In this case, we had a contractor who we were working for, who's a principal contractor on the role, and they are familiar with blasting operations. So we were to some extent preaching to converted. But it's always a question of what is theoretically possible and what is modelled and so on. And if it hasn't actually been done like that before, there is always the element of unknown. And in the nuclear industry, you've got to disprove the unknown before you're going to get the green light to progress.
I think trials are for different reasons for different camps. So for the nuclear camp, the trial was about the noise and vibration. For us, that was of interest, but it was more a dry run of bringing explosives into a licensed nuclear site, preparing them, the aggro around, that process itself. So they were more interested in noise and vibration. We were pretty confident with our predictions. We knew exactly what was going to happen. It was a very small amount of explosives in a very confined environment. We, from the trial aspect, were more interested in the logistics of us doing the job and how we would price a job associated with the extra steps needed for the nuclear process. All the paperwork's completely different. Luckily, the nuclear sort of regulators quite on board with helping us. The ultimate client, the Nuclear Restoration Service, they have sort of teams in place to convert demolition methodologies and risk assessments into nuclear themed paperwork of how they do things. So I think the first trial, we kind of knew it was going to go bang and we knew there was going to be cracks in concrete. The nuclear people were excited to see that. We were more interested in the actual practicalities of could we do it. It wasn't at that point a technical problem. It was purely a logistical. Can we get explosives that are clearly prohibited on the sign when you walk into a nuclear power station? Do not bring explosives in. Can we put them in the back of a pickup, drive through an airlock, put them down a hole, form an exclusion zone, press a button, and no one's going to come out of a shed shouting at us, isn't it? Yeah.
At the gatehouse, at the security lodge at the station, they have a sign of the following items are prohibited, and we were sort of playing security bingo. Yep, we've got that one. Yep, we've got that one. We want to bring that one in next week.
We didn't have a pet and we didn't have a firearm, but everything else we ticked well. And what we were saying about Sizewell, it's understanding explosives place and the key market indicators of, in London, it's time and noise. Sizewell was time and noise, and they were the two things that we eradicated at Sizewell. We slashed the time needed afterwards. We were working concurrently whilst they were deplanting in the drilling phase, so we didn't need our own standalone time. We just needed 2 weeks to charge of our own time in the turbine hall. So ultimately, our programme, whilst we might have been on site for 2 months, we only needed 2 weeks off that programme window, and in turn we saved a multiple of 2 weeks off the programme and allowed them to use smaller plant that could be easily lifted into the basement rather than trying to get 80, 90, 100 tonners down there. They could use existing infrastructure to drop machinery in there. It was machinery that ultimately is, a sort of a multiple cheaper. A 50 tonner is half the price of a 70 tonner, even though it's almost the same weight. They're not, 70 tonners aren't twice as productive, but we can bring larger jobs down into that kind of higher fleet range of machinery rather than ultra specialist one-off machines. And it's trying to understand the value that we create by doing that. Along with noise, vibration. Going forward, I've been having quite a lot of conversations with sort of nuclear businesses and contractors who work in the nuclear environment, and it's trying to understand that where cost is inhibitive in the wider world for blasting, in the nuclear world, is it the environmental performance that you gain in such a sensitive environment and the program gains that you can achieve in such a sensitive environment worth the value? And the kind of traditional value structure that I've grown up understanding in demolition is completely on its head in the nuclear world, and their priorities are ironically quite similar to central London in terms of if you can speed something up and if you can take the noise and take the dust away and make something into one focal event that they can plan, manage, evacuate, move stakeholders away, perform it on a weekend when there's no one working, they're really interested in stuff like that. So hopefully, we'd love to do more work with them. We can shave a lot of time off paperwork in terms of, going forward, we're trying to work with them to avoid lifting operations where it takes a long time to bring cranes in and understand the dynamics of cranes and how that works and the risk. Can we fell much smaller structures than we'd be used to felling? But de-risking the process, taking away the craneage, taking away the risk, taking away the paperwork associated with that and speeding the whole process up.
We've been doing it. I've personally been doing it since 2005, but I joined John Faulkner then, and he'd been doing blasting for many years prior to that. So my background originally goes back to actually working for an explosives manufacturer, and I was testing experimental explosives and doing performance testing on them. So this sort of falls in very nicely with what we were saying a few moments ago about trial blasting and so on. I understand the data that can come out of trial blasting, and it might not just be the obvious information. There's usually secondary learning that you can pick up in as well. Electronic detonators have revolutionised things, really. Using non-electric systems, well, originally we were using electric systems, and they literally relied upon a voltage going down a wire to fire things, and you can have problems with stray currents and leakage and misfires and all sorts of problems. Then the non-electric system came along, which is great because that's completely immune to any issues from lightning or anything of that nature. But the problem with that is you only have set time delays. So it's a little bit like Lego bricks. If you want a Lego brick that's got 5 dots on it, you've got to choose, but either take one with 4 dots on it, or take one with 6 dots on it, or mess around trying to add 4 and 1 together, or 3 and 2, or whatever it may be. So when it comes to doing things like tower blocks, for example, to control where a tower block goes and how quickly it comes down and where the debris lands, and also more importantly what vibration levels you get, timing is absolutely everything to you. So using the electronic detonators completely revolutionised that. I think that's the biggest change we've had. But we can manage noise and vibration far more extensively than people might think. We did some trial blasting a few months ago now where we actually let off, I think it was 2.1 kilos of explosives in the central Westminster. Nobody batted an eyelid. No. You'd be surprised what we can do quietly. And 2.1 kilos of explosive is sufficient to break out, depending on what it is, 6 or 8 cubic metres of concrete. How long does it take to knock out 6 or 8 cube of concrete with a 50-ton machine? How much noise do you make? How much diesel do you burn?
And it brings it into the realms of, we can come in out of hours, we can be drilling during the noise periods during the day, 5 o'clock when everything gets a little bit bustly and the noise starts to pick up in the city and the commuting starts, we can be firing off shots then, oblivious. No one has a clue what we're up to. We don't need movement orders, we don't need to bring 70 tonners into central London, it's us in a pickup truck. We've got innovations that will keep ourselves relevant, and that's our challenge now. We can't just rely on work coming to us, we've got to push out into marketplaces, we've got to establish our own workflow. There's no point relying on clients coming back to us. That's great, we love repeat business, but we want to be forging out into the energy market out in the North Sea, we want to be coming into the renewable market. There's been a lot of evidence in America of lightning strikes damaging turbine blades, high wind events damaging turbine blades, and those turbines have to come down as quick as possible. Or when you build something up the side of a mountain, it's quite difficult to get a 1,000-ton mobile crane back to it. Again, we can turn up, cutting torch, pickup truck full of explosives, and it can be on the floor within a few days. So it's trying to understand that, where do we go next? Traditionally, it's been a market that's been fed by bigger companies down to us as a subcontractor, but we now need to push out into other niches and develop our own marketplaces and stay relevant, basically. It's the deindustrialisation of Britain's almost finished. I'm quite excited that hopefully next year we're going to fire a coal-fired power station. That's great. Hopefully there'll be a couple more in it for us, but that's it. I don't expect to be firing them for much longer. It's a skill that I'd love to learn. It's a skill that I'd love to have, but it's not going to be my career. My career is going to be going off into much different tangents, and it's not just explosive demolition we're looking at. We've realised that our skill set's so applicable, so broad, and that kind of, Hexham House, how far are we to the substation?
6 metres.
6 metres. We didn't even get enough vibration to cause light finish work damage inside. We were 2/3 of the light damage vibration limit, and we predicted that with a high level of confidence that was the vibration we were going to produce. It wasn't guesswork. It wasn't. It was science. Trying to bring that out into other environments where we can say to people, we can actually use explosives to help you in what you would traditionally worry about with sensitive assets, close to other things, in dangerous environments, taking people out of the front line, setting a charge, ultimately retreating back to a safe distance, pressing the button. From a practical point of view, I just sort of took a step back and thought, do I really want to be hedging my entire career's bets on my generation deciding to suddenly want to turn off the Xbox and come and do demolition? I wouldn't. So I sort of looked at, well, I'm a very practical person. I love practical work. I couldn't sit in an office all day. It would kill me. And I thought, well, how do I combine the most practical thing I can do with the biggest impact with the highest level of technique, technical skill, engineering? So that's my passion. And essentially the sort of Venn diagram picked out, this is the optimal solution of, I can do 3 months in an office to work. I can do site visits to go and be involved in the whole project, and then I can turn up for 1, 2, 3, 4, 5 weeks, depending on how big the project is, and then ultimately a satisfactory press of the button, buildings on the floor, leave the mess, and retreat back to the office.
Cormac's initial approach to me was, would I consider training him? And my reaction to that was yes, because we need to do something about career succession and handing the knowledge on. There aren't any textbooks particularly on our subject. There's a few presentations been written, but there isn't anything terribly well documented. But on the other hand, I didn't want to set up somebody who was then potentially going to trade as a competitor. So those discussions sort of bounced backwards and forwards, and in the end I said, well, would you be interested in buying into the business? And at that point, the planets had come into alignment for Cormac.
It's kind of the old, we've lost the old apprenticeship system. This is old 200-300 years where you'd go to the best craftsman you could possibly find, who was towards the end of their career, and then you would try and buy into his business to learn his craft. And we've lost that completely. And then you've ended up with, okay, fair enough, there's not many skills left where it's of such a small scale that there are highly skilled specialists in that field. But explosive demolition is definitely one of them. And we've seen a lot of explosive demolition engineers exit without training anyone behind them. And there's I think there's By the time Robyn retires, there's 4 of us left in the UK. PDC would have 2 of those.
I produce drawings using a very elementary graphic system, which are known between Cormac and I as my caveman drawings. He's now got me tuned into AutoCAD, for example, which I'm still fumbling around with a little bit, but give me a few more months. And I can see that there's also a lot more scope for sort of the modelling on what we do. You know, we can analyse how fast a tower block came down, how fast it accelerated. We know what time delays we used. We know what results that's achieved. We need to get a little bit smarter in terms of how we model that rather than just using simplistic Excel sheets. There's got to be a better way of doing it, and it's something that Cormac and I were talking about actually last week. So
I think it's, you know, we've hired another explosive engineer, and it's hit a nice point now where, not yet, but theoretically at some point we should have time, and with time you can sort of improve. Rather than firefighting, you can put systems in place to make the next time you do something less painful. At the moment, we're quite reactionary. You know, a job comes through the door, we sort of have a look at how we did the last chimney, when we go through that process again. It's trying to take myself out of the coalface per se, and trying to sort of look at how we've previously done chimneys, create a system to speed that up so that the next time that we do a chimney, it's not a 3-day event, it's a 2-3 hour event. Temporary works is a beautiful thing in that regard, where some things in temporary works are extremely repetitive, like formwork, and you can build systems and build spreadsheets and build automatic report writing to the point where the job becomes administrative. Now, equally, you have to have the experience, which is where Robyn comes in, to check that speed line process. You can't just speed something up and trust what comes out. It's quite useful that the 3 people that would be doing the work will have all done the work manually previously. I would never give a streamlined tool to a newbie, because they would just trust whatever pops out the other end. But it's trying to use technology to leverage our time, because ultimately we're merchants of our time. We do produce outcomes, but we attribute all of our outcomes to a certain amount of time, and that's the rate that gets billed plus materials. So trying to streamline that and get more work through the door would be my ideal. And then it's just harnessing the most advanced technology I possibly can to do that. And some of that is actually finding other younger people out there who we work with a great engineer from down the southwest who's been trained by one of the best, and he kind of is not afraid to harness new technology, but he's been taught the old way, so he understands what comes out. He's not doing it because he can't do it manually, he's doing it to speed up his day-to-day. So it's trying to find other people that have endured the pain of manual work and now want to harness technology. So that's where we're in an advantageous point. We've done it the old way for, well, we've had John's years, 40, 50 years.
Yeah.
Add Robyn on top of that, we're up near 70 years of hand calcs. I've done 3 or 4 years of hand calcs. So we've got 75 years of hand calcs. Now the computer's throwing some hand calcs back out at us, and we can pretend to be checkers rather than manually doing it. So,
for instance, we've long since been using Excel spreadsheets and things to calculate charge loadings. And that gives us answers in metric units, cubic meters, kilograms of explosive, and so on. Those numbers don't necessarily mean a great deal to me, because the way I learned to do it is using cubic feet and pounds. So I can look at a charge design and I can say, yeah, there's that many cubic feet in there, so that's going to want about this amount of explosive in it. Divide that by 2.2. Yeah, the metric answer comes out there. Yeah, that's given me a sensible answer, I'll go with it. It's just the ability to do a quick sanity check, as I call it.
Management memorandum number 1 was banning the use of imperial units across the whole company, which didn't go down very well. And within about 3 weeks, Robyn asked me how big was a beam, and I went, it's about a foot square, and I was absolutely heartbroken that I'd turned up going, no, we're not using imperial anymore. And within 3 weeks, I'd reverted full circle. How thick's that? 8 inches. I was like, no, this is not right. But it's been interesting in that regard, because, like Robyn said, the reference material is old, and sometimes it's not worth converting the reference material. It's easier for me to change back. Most of what we demolished was designed in imperial, so I'm trying to convert something to be in millimeters, and it's just a stupid number, versus Robyn's going, well, it's a foot square, and that's a nice, easy, simple. And then when you look at a foot square and you look at a 3 foot length, that gives you a cubic feet, and then you look at the charge weight associated off the table and it gives you a number in pounds, and converting the pounds number at the end is a lot more simple than trying to work with 298.3 mil square. So that was I came and I said I wasn't going to go back in time, and I have had to concede slightly, but we've got Robyn on AutoCAD, so that's good. Our USP is that we bring science to something that looks untamable. It's a perfectly tameable thing. It's just a chemical reaction. It's a very quick one. To the untrained, it's quite scary, but it's like everything else. You can risk assess it, you can plan it, you can engineer it, you can understand what you're doing, and if you have enough experience behind you, you can do things that other people say is impossible. That Hexham House, great video if you watch it. That was a challenging project, but through the use of some very careful timings and very tactical drill patterns that other people just don't use in the industry. We're not looking at pre-weakening here. The pre-weakening's a very simple empirical calculation. It stands up or it doesn't. It's the second order effects of when clap starts. How quick is something dropping? How far will it drop before it gets restrained? What's the stress levels on the back? Okay, well, there's more holes on the front than the back. That allows the back to crush, but it crushes at a slower rate. That gives it the tip. Or we don't want it to tip too far, because if it just falls over, then everything we've tried to do to remove ground vibration, if you just knock something straight over, the ground vibration is back. So it's quite an interesting one, because I'm a pure scientist. Science, numbers. But there's a touch of art. And that's annoying, because there's no science. But that's the experience.
The explosives are purely a tool to remove support. Now, you could make a tower block fall down. If you blow every wall out from underneath it, it's only got one choice. It's going to go downwards. But as Cormac says, it will come down with a big thump. You don't really know where the debris is going to spread around where you don't want it to go. So what you do is you approach it from the structural perspective, so you can put your explosives completely to one side at the moment. And you say, right, if we remove that element there, that's going to cause that bit to do that. That's going to have this effect on this bit, but then that bit's going to attach to that bit, so we better blow that bit out from underneath there. That's going to allow that to do that. And you sort of go through it in an iterative process. And then once you determine how much you need to remove and at what time you need to remove it, you then say, right, okay, here's our explosives. How are we going to do that? How much explosive do we need to use? What are we going to do so when that bit fires off there, it doesn't throw any debris over there and damage that bit that's not gone off yet? And that's where the explosive engineering comes in. So it's a very sort of logical, sequential process that we go through.
And then probably our main USP worldwide is we're one of very, very few of what I know of two that actually do their own structural engineering and explosive engineering. There's a lot of explosive engineers out there who sub-structural engineering out to other entities, but that just adds delay and complication to the iteration. Like Robyn said, it's purely an iterative process. Can I remove that? No. Can I remove that? Yes. Okay, what's the second order effect of that? How are you going to remove that? And it's structural engineers, explosive engineers, sometimes we're in the same hat, just going that back and forward, where you want to minimize the amount of explosives you use. Like, there's no two questions about that, because they bring their own massive set of risks involved. You can't take too much material away because there's a massive set of risks there. But then it's one step further. It's, where do you want the debris to go? How do you want the debris to field? What machinery have they got coming afterwards? Can they realistically take a boiler house if you just knocked it on its side? No. Okay, so it needs a lot more cutting vertically up through the middle to try and get it to slide out into a neater heap. And it's understanding all of that. And then everyone's got an obsession with building brand new buildings right next to what we're blasting. Don't know why they're like that, but they do. And then we do it 5 years after the building's closed down, so it's decayed, it's rotting. It's there was steel elements on the oil rig we worked on in Scotland that I sort of went over and gave the old engineer's boot to see sort of what thickness it was, to see if it rang true, and I put my boot through the flange, and I was like, okay, that's a structural steel, clearly not doing anything. And trying to understand buildings are an absolutely incredible thing where they will redistribute loads so well. And when we get to these structures and they've had a bit of abuse and someone's modified them in the past and it's not been recorded, all those new load paths, all that new sort of understanding of how it works, you've got to go right back to first principles. Like the amount of arguments me and Robyn have had about, using the web of a steel to bear load. That's an absolute no in university terms. They're not there for that. But in practical terms, it's a piece of steel, it's square in profile. Of course it'll take load. And it's that kind of process of winding back my engineering away from a code necessarily back to just pure first principle analysis. And then as a result, the work I do is so much more expansive. Where it used to be, well, you'd reference that bullet point in a code and you'd write 3 lines of calculations. Now you've got to understand where that code's got that bullet point from. What's behind that? What's behind that? What's behind that? All the way back to first principles. Work your way all the way back up. And something that you said you'd have it done by lunchtime, 2 weeks later you're still writing away, and that's where it's a little bit more tricky. I'm struggling to gauge the amount of time some things take, but it's good. One of the most ironic parts about Newcastle, and I won't name which one it was, but one of the kids, after they pressed the button, dropped a 17-storey tower block I'm 23 and that was still an absolute buzz. Like, I was pale with sweat and fear beforehand, and I pressed it and it was pure adrenaline, nothing but adrenaline. And this child turned around to me and was like, is that it? Is that it? And I was just like, what? So to me, yeah, like, it's the most exciting, I don't want to gender it, but it's the most boisterous thing you could possibly do. You know, I go down to the pub with my friends, and some of my friends have really interesting jobs, and I still laugh and go, yeah, but I blow buildings down. You know, that's my job. I turn up, I sell buildings for fun around the world. Like, I travel the world, see the world, and do it. And to me, like, I couldn't think of anything more fun to do. Maybe I'm strange in that regard, but I'd like to think that, you know, wielding that much power with precision in the future would be something kids would be interested with. And there is a lot of screen time involved. You know, there is a lot of high level engineering, there's a lot of modelling to be done. Like, it's not, I wouldn't call it the world's most practical job, but it's, I couldn't sit in an office. So it's the perfect balance for me. I've said our market's diminishing. I'm well aware of that. A lot of people have said I'm crazy for this. It's a diminishing market. That's a challenge to me. I'm hell bent on pushing hard into other markets. They're not even there yet. You know, there's stuff out there that we can do better than anyone else, and we don't even know it yet. So it's going to be trying to figure stuff like that out and trying to understand where we can help other people. We're reactionary, we're quick, and we think. There's not a lot of people left that do that. A lot of people like the comfort of being within the realms of a clear, defined code. You know, structural engineering of a new building is a code-based, code-bound. If you want to innovate outside of the code, there is mechanisms to do that, but they're extremely long-winded and difficult. Our industry is reliant on experience and first principle understanding, and it's quite cool that then means that you're free to be nimble and you can move into completely different markets that we never dreamed of. You know, there's so much work that out there that doesn't necessarily currently have the label of explosives over the top of, and it's trying to find that sort of work.
There's one example that's in my mind at the moment now. I don't want to say what it is for sort of commercial reasons, but it's something that we've been doing a little bit of research on, done some trials work on it over the last sort of 18 months, and we could see it could open up a very, very big market that could basically be the future of this company, certainly for the next 5 years, without anything else happening.
And that's just in the UK.
Yes.
You open up the global aspect to it, and it's outrageous. And then you add into the fact that the work that we're doing is in the UK. The way I describe it is, the bit that fascinates me is the UK is de-mechanising as well. So people are realising that explosives can help because it doesn't need plant. And we're de-mechanising from the green perspective, which is great. Reducing emissions, brilliant. Can we take the 570 tonners out of that process? Yes, we can. Brilliant. Let's take them out. Let's use some chemicals. But the best part about that is, in emerging markets, it's like a bell curve. We're at this end of the bell curve, but the other end of the bell curve is developing markets around the world that don't have access to 70 tonners. So we've got two bites at the apple. We can hit and target, you know, the decarbonising world hard, bringing efficiency, but we can also go to places that haven't had the chance to buy huge mechanised piece of kit and do the exact same role there. And the other advantage is there's structures out there that there are other methods that are better, but ultimately, you know, if you want to bring a high reach demolition team over to the Middle East, you need a driver, you need a fitter, you need someone to get it there, you need a supervisor, you need a contracts manager, yada, yada, yada. If you give us a building in the Middle East, there's three of us. We don't need supervision, we don't need babysitting. You know, all of our back-end paperwork-wise will all be based in the UK, normal people that we use every day, day in, day out. It's another job. Geographically, we could not care where it is. As long as you can get us explosive materials to there, we'll adapt our methods to suit that brand of explosives, that type of explosives, whether that's through testing, understanding. I mean, we're tendering out in Australia, and that's a lot of off-site testing. But if you can get us explosives, we can bring buildings down that logistically are just impossible for other methods. And that's where I want to expand. And there you have it. Cormac McLean, the younger guy, and Robyn Rushforth, the more senior. But yeah, that was the story. Some fantastic comments here that I have to go back to. What do we got? Dan Cullen saying, "Wow, interesting about getting concrete off steel." Yeah.
I think we tend to look at explosive demolition as it's an either or. It's a top down, or it's a higher reach, or it's explosives. Explosives have more than just that, and I think Cormac explained that very, very well. I take my hat off to this amazing young man, only 23 years old, taking on a management buyout of such a well-established company. I wish them all the best for the future, as do I. We'll come back to another comment that Gary has made there. For those of you in the demolition know, the name McLean may be familiar. Obviously, Cormac McLean is actually the son of Adrian McLean, who is the head. He is the head of the Institute of Demolition Engineers from Armac Demolition. The reason I didn't mention that in the video, and the reason I didn't mention it in the preamble, is because it's almost not important. Obviously, Cormac McLean has demolition in his blood. His father did it, his grandfather did it, uncle did it, and relatives all over the place. But I think you can see very, very clearly from that just, even though he does have that in his blood, he is very much his own man. And listen, I said at the top of that video, he is the future of the explosive demolition industry, and I believe that wholeheartedly. Trust me, he hasn't paid me to say that. In fact, he's probably sat there cringing as I'm saying it, but it's absolutely true. Definitely, Gary, well done to him, and he has an interesting knowledge too of the industry. Yes, he does, and a passion for it. And I feel it was interesting the fact that he's coming at it from a different angle. I think because a lot of our old explosive engineers, I'm talking about sort of previous generations, possibly came to demolition from maybe a military background. So they'd worked with explosives in the military, and then they brought that expertise here. He is coming at this from a completely different angle. He is an academic. He's clearly a very, very smart guy. And trust me, I was in that room with them when that was being filmed, and I was the most stupid person there. I'm the most stupid person in the room most of the time, but really was completely outgunned in that occasion. Sounds like they're pushing the boundaries of explosive techniques in the demolition industry. I'm looking forward to see what projects they have planned for the future. I can't give the game away, partly because I don't know the full details, but we walked out of that room together, and those two went and got on a plane because they were going to plan something else. So, yeah, there's lots going on. Dan Cullen says, wow, 2.1 kilograms of explosives in London, not a flinch of anyone nearby. Yeah, although when you think about it, Dan, you're in and out of London, you know how it works. London is quite a noisy place anyway. So a one-off pop is probably, you'd lose it in amongst all the taxis and the cars and the people and everything else, but also surely that's preferable to a repeated hydraulic breaker or whatever it might be. Yeah, I think they've got the right answer there. Gary Muirhead says, this young man should be an ambassador for the demolition explosives industry because the passion and excitement he has is such a breath of fresh air. I hope the NFDC are watching this interview. I hope the NFDC are watching this interview, but I will point out, and it's not, it's a coincidence, but the two things are not linked. Obviously, Adrian McLean, Cormac's dad, is the president of the IDE at the moment. Cormac is actually the IDE's youngest member. The two things are not linked. He did that of his own volition. Tells you everything you need to know. Adam King, morning. Good afternoon, Adam. Good evening. Old school meets new school. Well done to you both. I wish I'd thought of that as the headline, because that is precisely what they've managed to do. And I particularly like Cormac's point about, the old style of apprenticeships, finding the best craftsmen in a particular field and then buying into their business so that you learn and then you inherit. And I think you couldn't have done that better if you tried. Joe Challet says, nice one, Cormac, a man of knowledge. Yeah. And for those of you that don't know, I do a morning. Well, some of you already do know. I do a morning show every single weekday, and we often talk about trying to attract younger people into the industry. That, I think, and I know it's an extreme, but buying into a company at 23 years old. I realise that's an extreme example, but it just goes to show what you could achieve. Well, if you were a young person and you had the right stuff, shall we say, it's you could end up doing like he said, travel the world and blow buildings up. What's not to like about that? Looks like they will be a force to be reckoned with in demolition. I heard about Cormac basically studying explosive demolition. I've bumped into him on a couple of occasions where I've gone to film a demolition, and he's been there. And he was there, as an invited guest, but he was there to learn. And I do remember thinking, when you look at the profile of the explosive demolition industry, certainly here in the UK, we've got William Sinclair up in Scotland at SafeDem, who's probably early 50s now, I would have thought. But apart from him, everybody else is at or beyond retirement age. All the explosive engineers. Cormac McLean, and I know he's looking beyond the UK, but he has basically got, or he will inherit, a market to himself. He absolutely will. Well done to Mark and Fred for an excellent and informative interview. I really enjoyed it. Thanks, guys. Thanks, Gary. Although, telling tales out of school. Fred wasn't there for that one, but he did do all the graphics on it, so I kind of have to say that. In a former life, I knew Derek Bates, Blaster Bates. He didn't like to share too much information. Would have loved to have gone to work with him. Somebody many, many years ago actually gave me a tape of Blaster Bates giving a lecture somewhere. Absolutely fantastic. Wish I still had it. I have no idea whatever happened to that. Dan says, amazing young man. Well done to him. Yeah, I totally agree. Quite noisy, all right, but would probably sound like a gunshot. But in some... it probably would, but, that one crack over and done with, as opposed to... That was my impression of a hydraulic breaker. It's not my best impression. I don't do any impressions. Andy Dyson, who was involved in the Sizewell blast. Good evening, Andy. Good of you to join us. And he says, perhaps predictably, well done to both of you. Sizewell was a blast. Yes. There you are. There's the headline written. Thanks for that, Andy. The Daily Show is one of considerable importance to the industry. Is it? It's just the way that I spend my mornings because I have no friends. That's what. But thank you for that. That means a lot. Thanks, Dan. And Gary Longyear. Good evening, Gary. Met Cormac and Robyn, clever lads. See you soon on our project. I'm just going to go away and check exactly where Gary's working right now to see where that project might be. But if you do happen to need a cameraman and his idiot father, please let us know, because I'd love to come and have a look at that. I would like. We're actually working on something in the background with Cormac at the moment, which we'll be bringing to at some point in the future. But I really would love to get out on and actually. I was lucky enough once to walk a explosive demolition site with William Sinclair, funnily enough, and with Mike Keogh at C&D Consultancy, and they showed me behind the scenes. But it was before I was really into video. So I basically walked around with a notepad. What a lost opportunity that was. Love to go and have a look around and see behind the scenes, the day before the blast when everything's being made ready. I'd love to go and have a look at that. So if there are any explosive guys out there, Cormac, William, anybody else, please let me know, because I'd love to come and do that. And clearly, we've got a lot of people in the audience tonight that are only slightly allied to the demolition industry. In some instances, they're not allied to the demolition industry at all, but they're interested in the subject matter. So if we can get an opportunity to do that, we most certainly will. Anyway, I think that's probably going to do us for this evening. Hang on a minute, something just happened. There we are. Have a wonderful evening, guys. Yet another fantastic show. Thank you, Mark and Fred. See you all tomorrow at 10 a.m. You most certainly will. Yeah, anybody that's a bit of a newbie to this, we do a live show every 10 o'clock every weekday morning. If you are around, grab yourself a cup of coffee, or in my case, a cup of tea. Turn on LinkedIn or Facebook or YouTube. Come and find us. Join in. It's like this, only often more sweary, if you see what I mean. Gary Muirhead says, an amazing interview. Got me wondering how your interview with Dr. Terry will be like. Dr. Terry, yeah, Terry Cornby. I'm seeing him in about 5 weeks. 5 weeks. I should probably drop him a message and get him to gird his loins in advance. And listen, I'm hogging the limelight here, but, the man of the hour, Cormac McLean himself. Mark, thanks for your time interviewing us. Cormac, you know this. Pleasure was all mine. Absolutely fantastic. Nice spot of lunch as well, but that's a whole other story. But yeah, it really was an absolute blast. Thank you very much indeed, Cormac. And obviously, it goes without saying, but the very best of luck with the business. I don't think you need luck. I think you've got this. I think you've demonstrated that very well tonight. Any word on Yvonne? Haven't heard back from Yvonne yet, but I am chasing it. Don't worry about that. Can you ask people not to ring me at 10 a.m., please? Then I might listen to you. Yes, please. Anybody that knows Chris Ford, please don't ring him between 10 o'clock and 11 o'clock on a weekday morning, because he's busy. He's busy doing nothing, listening to me babble on. And if that's the sort of thing you're into, please join him. There's plenty of us, and we have a right old chinwag. Just a very quick heads up for tomorrow. Excuse me. We're going to be talking about, could the demolition and construction equipment industry see the arrival of a disruptor? You think about the way that Elon Musk and Tesla disrupted the automotive industry. Think about the way that Jeff Bezos has disrupted the retail industry. Think about the way that Cormac McLean is on the verge of disrupting the explosive demolition industry. Could we see a disruptor arriving in the equipment industry? That's going to be my morning monologue tomorrow. There's plenty of other stuff to go through as well. But for me, it's dinner time, and which means it's good night. Everybody, thank you ever so much for being here tonight. Really enjoyed your company, as always. Thank you, Cormac and Robyn, for giving me the opportunity to do that interview. You can watch this on Catch Up. There's a better quality version of this. Because I'm uploading that off my computer, it's not quite as good as it should be. But if you want to see a proper, crispy 4K version, go over to YouTube. It's youtube.com/Demolition News 1, and you'll be able to see it there. Everybody else, please. Let's have a look. Gary Muirhead says, fingers crossed I'll have a single for tomorrow so I can tune in. As you well know, Gary, the show isn't the same without you, so I sincerely hope you can be there, but fully understand if you can't. Everybody, have a fantastic evening. Thanks for your company. I'll see you tomorrow, if you can be there. Till then, have a good one.